Assalamualaikum and very good days. So for the class today, we continue for the line integral by using the Green theorem. So how we can solve for the line integral by using Green theorem. So Green theorem, this is the one of the method that we can use to solve for the line integral. And by using the Green integral, so you can make line integral become more easier. So the first thing you need to find that the line integral for the Green theorem must be in term of the this one so the line for the integral must be in the form. The first thing, simple, closed and piecewise smooth curve. So they have the three type of the boundary, so they must be oriented either in the counterclockwise or clockwise. So the basic formula, this one is the line integral for the vector scalar. So when you found this one for the previous topic, we can solve this one by changing the changing this line integral from the 2 or 3 variable into change into the single variable. That is the previous topic. So by using the Green theorem, so you need to use this formula. This formula. So this formula for the counterclockwise, ke sana, contoh kalau you have the circle, the line integral close, line integral, so clockwise ke sana lah, y, z. So this is the line integral, that's y, x, line integral, so clockwise ke sana lah. So you need to using this formula, double integral nm, nm, so this one mn, so all this m and here m, so m represent for x, n for y. So m the x here, so you need to partial derivative respect to the y, the y besar lah, but respect to the y. For the n, the y, so you need to partial derivative respect to the x. So you need to look here, be careful, jangan tengok mn sini, so you need to look for the dx dy too. For the clockwise, so you just letak je lah negative here, senang. nm tolak ni, so sama je kalau you pusing belakang, sama je. So better, senang, you just put negative here. So you ingat satu je, counterclockwise, and then for the clockwise, you put the negative here. So kalau you put ni dia, so you simplify, dapat yang benda sama juga. So tak nak pening-pening kepala, you just ingat satu formula here, nm, n tolak m, dA, and for the clockwise, negative. That's all. This is the formula for the Green theorem. Let's say we do some example. So this one can be applicable for the scalar field and also for the vector field. This one scalar field, scalar field senang lah, they just directly given in the term of the scalar field, and then you just using the formula and solve the line integral using the Green theorem. Let's say we do for the some example. So by using the line integral, use Green theorem to evaluate. Green theorem to evaluate. So this one kata close lah. Kalau selalu this annotation atau this symbol represent for the close line integral. Close, smooth and or close and smooth line integral. So C, so x kuasa 3 dx, plus xy dy, where C is triangle kosong kosong 1 1 kosong 1. So the formula is double integral, formula dia double integral partial n dx tolak partial m dy. This one for the counterclockwise. So you do sketch the triangle, start from 00 11 01. This one 00 11 01. So dia punya arah is the counterclockwise. So counterclockwise you using this one lah. Kalau if the line in the orientation line in the clockwise ke sini, so this one akan letak negatif. Ni counterclockwise. Okay, you can using this one. So you tahu ni dx. So this one represent for the m. Ni dy. So represent for the n. Tengok ni dx dy dulu Sometimes question dia depan belakang. So you kena hati-hati, kena faham. So kalau this one direct x dia susun betul macam ni. Bukan betul lah, dia arrange this line integral in the typical form. So okay, you can directly noted that this one as the m, this one as the n. So partial respect to the ni region So partial m and respect to the x. Okay, dia tinggal n respect to the x. So partial x, so dia tinggal y. So m respect to the y kosong lah. Tak ada y sini tak ada y no y here, no y here, so 0. This one ada x. So x partial dapat 1, so tinggal y. So this one 0. This one 0 di A. So you dah dapat betul dalam double integral. Sama macam sebelum ni lah, similar as the previous. So dA can be as the dy dx or dx dy. So which one you want to solve for this for dA? Let's say you want to use the dx dy. So dx, this one as the dy. So dx first, kalau first must be look at the line. So line ni saya tukar kali lain lah. Ni macam revision lah. We do some revision for the line integral. Okay, so you look this line. So x start from 0 and up to this line. This line ni x sama dengan apa? X sama dengan y, because ni 0 0, sini y y. When the x 0, y 0, x 1, y 1. So x equal to y. So sampai y. Kalau tak, you kena buat lah. Y sama dengan mx tambah c tu yang sebelum ni So m tu apa? Razor y, razor x. Okay, so and then selesaikan lah. Kalau this one not y equal x, okay, but when you look at the point, this one x equal to y. Okay, and then y. Okay, y you need to look at the point. So point ni kosong, and point ni sama. Point sama, so point ni adalah 1. Dah selesai. This is the way how you can solve for the line integral using the Green theorem dA. So you using dx dy. So x start from 0 to y. Y start from 0 to 1. Integrate to y. So you dapat x as y. Okay, dapat. So this when you integrate respect to the dx, so the answer is the y xy. Okay, xy. So 0 to y dy. So you substitute dengan kosong lah y. So y kuasa 2, y kuasa 2 dy. Start from kosong hingga 1. So integrate y kuasa 3 per 3 kosong 1. So the final answer is the 1/3. Semua dah simple lah, dah senang lah. So yang new method hanya this part. Okay, this part. Okay, method dia how you can form the scalar function, scalar vector. Okay, this one scalar vector because in the term of dx dy, scalar vector. So when you look this scalar vector using the Green theorem, so you automatically using this formula lah. Okay, so m ni must be dx lah, and is the dy. So m bila dx partial respect to y, bila y partial respect to the x, vice versa, dia terbalik. Okay, vice versa. Okay, so we try for the next example. So sama juga use Green theorem. Using theorem. So they given the line integral. Okay, C X kuasa 2 Y plus X kuasa 3 dx plus 2xy dy, where C is path boundary by y equal x and y equal x square in counter clockwise orientation. Okay, counter clockwise orientation. So first step, the formula. So you know the formula is Green theorem. Green theorem formula is double integral partial m respect to the y tolak partial n respect to the n m okay, partial n respect to the x tolak partial m respect to the y dA. So tahu this one m, this one n. Ni adalah m, okay, x, so the respect to y, and so dy respect to the x, partial respect to the x. So diselesaikan dulu, double integral. So n respect to the x, so x here, so you partial derivative, so dia tinggal 2y, okay, dia tinggal 2y. So this one tinggal 2y, sorry. y tolak ni m pula respect to the y. You tengok sini y, so dia tinggal partial respect to the y, so x kuasa 2. So this one ada y tak? Tak ada, kosong lah. So tinggal dA. Okay, selesai. So this one double integral 2y tolak x kuasa 2 dA. So dah settle this one. So you need to find the boundary region. Okay, the region. So region dia kata y sama dengan x. So you plot y sama dengan x, bounded path boundary by, so y sama dengan x, sini dah y sama dengan x here. Okay, y sama dengan x, and then y sama dengan x kuasa 2. So senyum lah, y sama dengan x kuasa 2. Okay, so in first altern, in the first altern, kita lihat first altern lah, first altern, so sini lah, here, so counter clockwise, arah dia ke sini. Okay, so area ni yang dijadikan sebagai, that is the region. So you nak pilih apa, dy dx or dx dy? Dy dx ataupun dx, which one you want to start? Okay, let's say you want to use for the dy dx, so dy dx, so y start, so tadi dx dy, ni kita buat dy dx pula lah, dy dx. Okay, so y start, kalau first must be look at the line, so pop kena line ni bersamaan dengan apa? Y bersamaan dengan apa? Y bersamaan dengan x kuasa 2, and pop kena line ni y sama dengan apa? Y sama dengan x. Okay, settle. So and then you look for the x pula, so x pop this line ni, x bersamaan dengan 0. Okay, and then pop kena line sini, so this one x sama dengan apa? So nak dapat sini intersection, bila intersection you kena samakan lah. So this one y sama dengan x, So letak X sama dengan X kuasa 2. Okay, so X tolak X kuasa 2 sama dengan kosong. So X sama dengan 1 tolak X lah. Okay, dan kosong. So X sama dengan 1 plus minus 1 lah. X sama dengan 1. Okay, so this one adalah X sama dengan 1. So intersection dia pada X equal to 1. Selesai. Ni saya rasa dah banyak kali buat kalau intersection je. So kena samakan lah. Okay, and then you can form double integral. You nak guna tadi apa? dy dx 2y tolak X kuasa 2 dy dx. So y start from X kuasa 2 to X, and X start from 0 to 1. Kalau you nak gunakan dx dy pun boleh, dx dy pun boleh, tak ada masalah. So X start from, kalau first kena tengok line, pop kena line yang ni dulu. So X start dengan Y, and then X end up to the X end up set Y. Okay, sini dah. Ni sama dengan this line sama dengan Y kuasa X kuasa 2. So X sama dengan set 2 lah. Okay, set Y. Set Y settle. Lepas tu Y sama dengan kosong. So sini samakan lah. Masukkan Y dalam sini. Y sama dengan X sama dengan Y. So sini akan jadi Y kuasa 2 lah. Y sama dengan X, Y sama dengan X kuasa 2. So X sama dengan Y, so gantikan Y sama dengan Y kuasa 2. So sama macam tadi lah. So dapat X, Y sama dengan 1, settle. So kalau you nak solve for the dx dy, double integral 2y tolak X kuasa 2 dx dy. So X start from Y to set Y, and Y end up 0 to 1. So the final answer is the 1/12. Okay, 1/12. Okay, this is the line integral for this answer, this question. Okay, jawapan masih sama lah. Either you using dx dy or dy dx, the answer must be same lah. Okay, so saya tinggalkan satu soalan. So you selesaikan untuk soalan ini. Okay, the given the use green line, green theorem. Use green theorem. Lah, suka sangat lah buat kecil. So this one nama khas So for the final exam nanti, so you look lah the question either the mention for the green theorem ke apa theorem, so using. Kalau dia tak ada mention, never mention for the green theorem, so jangan guna green theorem, you kena gunakan basic formula lah for the line integral, basic method typical method. Okay, so use the green theorem. So the given line integral x kuasa 2y dx, okay, plus y kuasa 3 y kuasa 3 dy. Terbalik. Sorry Okay, x kuasa 2, y kuasa 2 dx. Okay, dy, this one dy respect to x dx. Okay, dx, okay, then this one dy lah. Okay, dx dy. Okay, so this dx, this one dy, where c path from negative 1 0 to 1 0, and x kuasa 2 plus y kuasa 2 equal 1. Okay, the path bounded bounded from 1 to 2, and x kuasa 2 y kuasa 2 equal to 1. Okay, you need to solve this one using the Green theorem. So this one line integral lah. Okay, so sama macam Green theorem tadi, cuba selesaikan. Okay, so jawapan dia negative pi per 8 So the answer is the, so kita cuba selesaikan. Okay, so now we proceed for the next method. Same method, but we need to solve for the vector field. Okay, this one scalar field and then this form we need to solve for the vector field. Okay, this one Green theorem. Okay, Green theorem. Vector field. So vector field tahulah yang bentuk F simbol F, vector field. Okay, so let's say the formula, this one the formula dia. Okay, this one formula. Okay, formula. Okay, this one formula for Green theorem. Formula for Green theorem. This one formula for the Green theorem. Okay, for the counterclockwise. Counterclockwise. Okay, counterclockwise. So for the Green theorem, the line integral must be in form of the linear in form of the vector scalar field, must be in this form. Okay, barulah you can use for the Green theorem. So let's say the vector field you tahu f x y equal mi plus qj. So in this form. Okay, sama tak bentuk dengan ni? Tak kan? Tak sama kan? Tak sama dalam bentuk line this scalar field. So you know for the line integral f dot dr, so you tahu f dot dr equal mi plus qj. Okay, dot dengan okay dxi, okay partial derivative respect to the x plus derivative respect to the y. Okay, so barulah you dapat bentuk dalam f dot dr. Okay, let's say fx equal this one and the r prime t equal xi plus yj. Okay, this component so when you found the dr, you get here you derivative this one, derivative dr, so x prime dx I plus dy j. So this one you substitute lah dalam sini and here dalam sini. So you dot kan. So when you dot kan, you akan dapat equal partial pi, okay, mi dx plus q dy. Okay, so this one dah buktikan bahawa for vector field dr, so you akan dapat bentuk dalam mi dx plus q dy. So you dah dapat lah bentuk dalam here, you dah bentukkan here. So you know lah, bila dalam soalan they given the vector field, so how you need to change this vector field in form of the scalar vector. How to form? So you just bring m and q to here. So m you bring here, q you bring here. Okay, so settle. No more I sini no more I when you dah selesaikan dot product, tak ada lagi I. Sorry, no more I. So this one dah buktikan bahawa for vector field, this one you dah selesaikan, so you can get line integral in this vector field can form this scalar vector. So when you found any question relating to the vector field, so directly you can transform the vector field into the scalar vector. How? You just bring the m here and respect to the x and q, component q all the component q respect to the dy. So bila you dah dapat bentuk here, barulah you can boleh gunakan Green theorem. Then you can use the Green theorem to solve for the line integral for the vector field. Okay, let's say we have some example. Okay, some example, given the use Green theorem. Use Green theorem. Green theorem to find work done. To find work done to vector field fxy equal x square tolak y square, okay, I plus 2xy j along triangle 0, 0, 1, O and 0, 1. Okay, so you need to analysis the question first. You need to analysis the question first, and then you found that. First using Green theorem. Okay, using Green theorem. So you gunakan using Green theorem, partial n, partial x minus partial m, partial y dA. This is the formula for the Green theorem. Okay, and then you find, oh ni bentuk apa ni? So you tahu fx this one adalah vector field. Okay, vector field. But for using the Green theorem, you need to change in the form of the scalar field. Okay, and tadi saya dah prove for the vector field can change but work done. Okay, by work done, so you tahu work done f dot dr. So this one you tahu bersamaan dengan partial m dx plus n dy. Okay, you found this one mn dy, dapat bentuk dalam ni kan, saya dah buktikan tadi. So bersamaan dengan m dx plus dy. So you need to form this vector scalar field first. So you tahu this one represent for the m, okay, all here m, and this one represent for the n. So to change in this form, so you just bring all this m x kuasa 2 plus y kuasa 2 dx, okay, and then n sama dengan 2xy dy. Okay, dah dapat bentuk ni tak? Dah sama tak? Okay, and then barulah you boleh, and then you can use the Green theorem. Okay, ni dah settle. Jangan tengok mn sini lagi dah, you proceed sini pula the formula. Okay, and then barulah you boleh gunakan this formula. So sama juga, this one m, this one n, then using this formula, line integral n respect to the x. So x tinggal 2y. Okay, tinggal 2y tolak m respect to the y. Okay, ni kosong jadi 2y. Okay, so tolaknya this one minus sorry, this one adalah minus y kuasa 2. So minus tolak jadi tambah. So tolak 2y dA. Okay, dah settle. Dah settle. So you tengok dia punya triangle 0, 0, 1, 0, 1. Okay, so triangle lagi ni. Okay, so dia counterclockwise lah. Counterclockwise, okay. Kalau if the orientation direction in the clockwise, so you just letak je negatif sini. Letak negatif sini. Kalau dia clockwise, so you tak payah pening-pening nak tukar ke depan ke belakang, tak payah. You just tambah, letak sini je. Kalau clockwise, tak payah letak negatif, minus. If the orientation or direction of the line integral in the clockwise, okay, clockwise macam ni, so you just put negative here. So but this question counterclockwise, so you can delete lah this minus. Okay, dah settle. Lepas tu double integral macam biasa. Saya rasa semua dah mahir, dah pakar how to find the boundary. So you boleh guna dy dx or dx dy. Okay, either one lah. So let's say you want using the dy dx. So y tak kena line ni, tengok line ni kosong, and then kena line sini. Line ni apa? So sini kosong, 1, sini 1, kosong. Okay, y sama dengan m. Okay, 1 tolak kosong, 1, so m1. Okay, m1 ya, mx tambah c. So m1, so y sama dengan x tambah c. So y kosong, x sama dengan y kosong, x sama dengan 1. Okay, so c sama dengan negatif 1. So you dapat y sama dengan m1. So ya, okay, kosong tolak 1 kosong tolak 1, 1 tolak kosong, so negatif 1 so ke kiri slanted to the left, so negatif 1 lah. So ni negatif 1, so negatif 1, c sama dengan 1. So c equal 1, so mx negatif x plus 1, ataupun y sama dengan 1 tolak x. So y sama dengan 1 tolak x, so this line adalah bersamaan dengan y equal 1 minus x. So end up to this line 1 minus x. So x start from, so second one look at the point. So point ni bersamaan dengan 0. End up this point bersamaan dengan 1. Settle. So settlekan double integral 2y tambah 2y, so jadi 4y. So you nak using the dy dx. So y start from 0 to 1 minus x. X start from 0 to 1. So the final answer is the 2/3. Selesaikan solve here, and then you get the answer 2/3. That's all. Okay, nampak tak? Nampak kenapa macam ni mn and y. Kalau you dah faham method ni, so you tak payah nak bentukkan ni, tak perlu nak bentuk ni kalau you dah faham the way here. Tapi kalau you tak faham ni, saya takut you confuse. So better you use transform the vector field to the scalar field first by the work done here. Work done ni dah buktikan for the work done for the line integral for vector field equal here. So you bentukkan ni dulu, dapatkan ni dulu. So you tahu this one m, this one n, and then baru jadi dapatkan dalam bentuk here scalar field. Okay, so you dah tahu for the line integral vector field sama dengan here, and then you selesaikan lah. Okay, let's say we do for the next example. Sama juga, use the Green theorem. Okay, use Green theorem. To evaluate line integral for vector field. Okay, where is the vector field? The given vector field fxy equal y minus cos y x sin y, where c is the circle x tolak 3 kuasa 2 plus y tambah 4 kuasa 2 equal 4 oriented clockwise. Okay, oriented clockwise. Okay, dia clockwise So using the Green theorem, so you kena form the Green theorem formula. So you list the color. Okay, sum partial n respect to the x tolak partial m respect to the y dA. So oriented clockwise, so letak dia negatif sini. Senang kan? Letak dia negatif sini. So this one you tahu for the line integral this one equal dengan line integral m dx plus n dy. Okay, so for the f, m, n. Okay, so you bentukkan line integral here, integral y tolak cos y dx plus n dia ni n x sin y dy. Okay, you dah bentuk here. Okay, so dah bentuk ni, barulah you boleh gunakan green theorem. So sama dengan negatif mn. Okay, n respect to the x, so x 1, so tinggal sin y tolak m respect to the y, this one respect to the y, jadi 1. Negatif cos dapat sin y, dapat sin y. Okay, so bila you tengok sini, tak 1 tambah 1, so negatif cosine cos negatif kan, negatif sin 1 negatif sin cos positif, negatif sin positif sin cos negatif sini negatif kan, jadi positif lah. Okay, sorry ni y dapat 1, negatif cos dapat positif sin. Okay, di A. Betul tak? Cos sin, saya pun lupa. Okay, and then you selesaikan. Jadi sin y tolak 1 tambah tolak sin y di A. Okay, so ni boleh cancel out, so dia tinggal equal negatif 1 di A, so negatif, so dia tinggal dA. Okay, so dA ni represent for what? So dA ni represent for what? So you kena tengok dia punya path lah, dia punya path ataupun dia punya line adalah x minus 3 square plus y plus 4 square equal to 4. This one you tahu lah, circle kan, circle at radius 2, circle radius equal to, and origin at origin dia, titik tengah dia ataupun center at, bukan origin center at x negatif positif lah, 3 negatif 4. So dapat circle 3 negatif 4 sini, circle kat sini. Okay, yx. Okay, so bila you dah selesaikan, dia adalah untuk dapatkan dA untuk circle ni, dA kawasan circle ni. So dA circle ni perlu tak you selesaikan this one? Tak perlulah, you just cakap lah this one sama dengan area of R ni lah, area of circle ni equal area of R. So sama dengan pi R square. So R dia sama dengan 2 square equal 4 pi. So dapat dah selesaikan. So you tak payah pening lah nak letakkan, carikan boundary ni So nak dapatkan boundary ni apa, R sama dengan apa, so quite difficult lah. So kalau dia tengok soalan gini, dah selesaikan, terus dia dapat lah for R. You tahulah partial double integral ni bersamaan dengan area of this one. Okay, settle for the green theorem. So saya tinggal satu soalan and then try to solve. Okay, using the green theorem, and vector field, given vector field, if the f x y x kuasa 2 plus 1 Okay, tan negative 1x, where C is triangle from kosong kosong to 1 1 to 0 1 and back to 0 0. Okay, calculate, find evaluate line integral vector field dot dr using green theorem. Okay, dia given here lah. Selesaikan soalan ni. Okay, so that's all for the today. Just focus for the green theorem. Okay, thank you.